Hey everybody, today we'll be talking about water, specifically 14.1, the water planet. So we'll be talking about fresh water, where it's available, and what we use it for. Our phenomenon for this week is about how water is limited. It's a limited resource, but it's also a renewable resource, meaning that we can get it over and over. So we're going to be talking about why it's limited even though it's renewable, and we should have access to it all the time. So water availability, 1/8 people lack access to clean drinking water. So even though there's a lot of fresh water, there's a lot of water on the planet, right? Not everybody has clean, fresh drinking water, and some people get sick. There's a lot of diseases that you can get from drinking water that's unclean, kind of like cholera. This usually happens in third world nations who struggle to find clean drinking water. All right, so it covers 2/3 of the earth. So where is all the drinkable water that we have? All right, so if you just look at this diagram, this shows you saltwater versus freshwater, and where all our water is located and what percentage is in what. So of our total water on the planet, 97.5% of it is saltwater, which is not usable for drinking, obviously. And then 2.5% of that is freshwater. So if this entire container were all the water on the planet, right, 97%, all this green section is going to be our salt water. 2.5% is going to be our fresh water. If you take this 2.5%, move it over here and look at all the fresh water, right? So of this 2.5%, 79% of that is ice, right? So it's frozen fresh water all up in the ice caps, right? 20% is groundwater, and we'll talk about groundwater, and then the 1% is surface water, right? So if you were to take this 2.5%, this is what it would come out to. This is what all of our fresh water looks like on the planet at this moment. All right, so seasonal availability, fresh water is not always available when it's needed, right? Obviously, it doesn't always rain when you need it to rain, right? That's what droughts are for. So there are many different areas of the world that have dry and rainy seasons. So certain areas have a season where it's going to rain a whole lot, and then there are seasons where it's going to be dry for a long period of time. One example of that is India gets 90% of their rainfall in 3 months out of the year. All right, so 90% of their rainfall for the whole year comes in 3 months. So it'll rain a lot during that 3 months, but then what do you do for the other 9 months? People are often challenged in moving fresh water to where it is needed and when it is needed, right? So we have a difficult time taking that fresh water that we need and moving it to somewhere else when we need it. All right, so surface water, like we said, 1% of the water is found on the Earth's surface. Sources are runoff, so water that is not absorbed into the ground during precipitation. So if you have rain or snow, right, and it comes down, hits the ground, it's not being absorbed into the ground, that's going to be called our runoff. Melting of glaciers, snow and ice caps, and then rain. So all of these things give source to surface water. Runoff will lead into the creation of river and river systems, and a river system is just a network of streams and rivers that are connected. So when you get runoff and it's not being absorbed into the ground, all that water is going to collect kind of as it travels downward due to gravity. And when it all travels downward, it'll start to create like a little stream, or eventually it'll turn into a river based on how much water is actually coming down. All right, watersheds. A watershed includes all the land area that supplies water to a river system. All right, so any area that it would or could spread water to a specific area is called a watershed. They can also be called drainage basins because as the water moves off of the land, it's kind of draining like it would off of your roof, and then it falls into your gutter. It's the same kind of idea. So the gutter would be the river and the land would be your roof. So they are important because it shows you where the water comes from to support a river system. All right, so it's important to know where water is coming from in a river system, especially because of pollution. it can really show you the effect that pollution has from one area has on our water. So if you had somebody who was polluting in a certain area, you would know which river their pollution would be falling into if you knew what the watershed looked like. So this is kind of what the watersheds look in the US. Now, these are all obviously the big watersheds. There's going to be smaller watersheds as you look at smaller rivers. So as you can see, the Mississippi River has a pretty big watershed. All of these rivers, the Ohio River, Missouri River, right, Yellowstone River, all these rivers are eventually going to flow into the Mississippi River, which will eventually lead to the Gulf of Mexico. All right, so it's important to know where the watershed, because if you have somebody polluting up in this area, right, eventually that's going to flow down to the Mississippi River, which will eventually start polluting the Gulf of Mexico. So the Gulf of Mexico, if you found it was more polluted, you would have to look through all this area to see who's polluting. All right, it also tells you that you have to work together in order not to pollute areas, because all this whole green section would have to work together in order to help the pollution of the Gulf of Mexico if it were polluted. All right, so groundwater is a little bit different. This water is going to be found beneath the Earth's surface. All right, it makes up 1/5 of Earth's freshwater supply. All right, so 1/5 of the Earth's freshwater supply is going to be found underneath the ground, 20%. It plays a key role in supporting the needs of humans. Most of our water that we get is going to be from groundwater. All right, there are layers underneath the ground that are permeable and impermeable. Permeable means able to pass through. Impermeable means not able to pass through. The reason that I put these definitions here for you like this is because next year, when you go to bio, you're going to be learning about permeable membranes and impermeable membranes. So I thought it would be important for you guys to see this definition now. That way you can get a little jump start for next year, so that when you see it next year, you'll at least have seen it before. All right, so permeable means it's passing through. Impermeable, not passing through. All right, water will be absorbed into the ground until it reaches an impermeable layer. All right, so it's going to keep falling until it hits a layer that it cannot pass through, in which case then it will start to gather there. All right, when it starts to gather, it's going to build an aquifer. All right, an aquifer is a sponge-like formation of rock, sand, and gravel that hold water. Right, and because of that, you're going to start to see a water table, which is the boundary between the zone of aeration and the zone of saturation, which I'll show you on the next slide. All right, they're just two different zones. The boundary between them creates the water table. It helps to know how far down you have to travel before you hit water. And then wells, that's typically how most of your houses receive their water. You can either have a well or you can get it from the water supply company. All right, but a well is a hole dug into an aquifer to reach the groundwater, and I'll show you all of this in the next slide. All right, so this is your surface. This is your surface water here in the river. All right, then you're going to have the permeable layer, which is this like sandy looking color, right? So the water is going to travel down through this layer, and then it's going to hit the bottom where it doesn't penetrate any further, which is the impermeable layer. So as you can see, it stops right here at the top. All right, the layer where you have a whole bunch of water, they call that the zone of saturation. So the water, as you can see, fills in all the pores and gaps in between the molecules. All right, so they call that the zone of saturation. Zone of aeration is what it travels through in order to get there. All right, so basically the permeable layer and the zone of aeration, similar. All right, so now if this represents your well, and you dig it all the way down, you need to go through the entire permeable layer deep enough that you hit the zone of saturation. Okay, so the well has to go all the way down, hit the zone of saturation. You want to go a little bit deeper than the top, right? Because if you stay at the top and you have a year where it's drier, right, and this water table sinks, now you're not going to get any water. So it's important that they go pretty far down into the water table. Right, this is what a dry well would look like if you built it down, but it's not deep enough, right? You get a year where it's drier. Now you don't, now you don't get as much water. or you don't get any water. Your well would be completely dry. All right, so the water table is this boundary or this line in between both layers. So the zone of saturation and the zone of aeration, where those two lines meet, right? That's what they call the water table. And that basically just tells you where you would be able to find water, how deep you need to go in order to find the water. All right. So it's very important that you have knowledge of where this water table is when you are building your well. All right, so that's it for 14.1. 14.2 will be coming to you soon.